Hi students, I have a new question for you, little bit theory touch question. Okay, the question is from 2025 CBSE paper 5573, question number 19. The question is, define the distance of closest approach. And next part, an alpha particle of kinetic energy k is bombarded on a thin gold foil. Derive the expression for the distance of closest approach. One part derivation is there and other part definition is there. Okay. Shall we start now? Okay, first part we are going to discuss the definition, that is the distance of closest approach definition. For answering this one, you will get half mark. Okay, half mark, total 2 mark question, half mark for explaining the distance of closest approach. So draw a small diagram to represent the distance of closest approach. There is a target nucleus is there and the alpha particle is coming to hit the nucleus. So it cannot hit because there is a electrostatic repulsion exists between them. So up to what distance it can reach the nucleus, that is the matter here. That distance is the distance of closest approach. So when alpha particle is directed towards the nucleus, the kinetic energy of the alpha particle goes on decreasing. The reason is repulsion increasing and it turns into electrical potential energy. So what happening is kinetic energy start reducing and electrical potential energy start increasing. And there is a stage where all kinetic energy will be equal to the potential energy. Okay. So at a certain distance d, look into the diagram. Okay. At a certain distance d, the kinetic energy of the alpha particle reduces to 0. So where it becomes 0, the distance from there to that nucleus, this distance is known as distance of closest approach. We are using the variable small letter d to represent it. Okay, this is the half mark part, just a definition. You can write your own way, but this is the concept. And we continue for the next 1.5 mark. At this distance, kinetic energy will be equal to the potential energy. Okay, at this distance, kinetic energy will be equal to potential energy. So K is equal to P, we mark it equation number 1. And we know that electrical potential at a distance d due to nucleus is, or any charge is, potential V is equal to 1 by 4 pi epsilon 0 charge by distance. Here the charge of the nucleus is Ze divided by d is the distance. So Ze divided by 4 pi epsilon 0 d we can write. Now the potential energy expression is electrical potential into charge. Electrical potential we wrote here. I gave a tick mark now. That is the one. So potential energy is equal to Ze divided by 4 pi epsilon 0 d into the charge of the alpha particle, that is 2e. Okay. Now we have potential energy expression with us. So as per equation number 1, kinetic energy is equal to potential energy. So kinetic energy equation is very common, right? Half mv square is equal to potential energy equation just now we made, Ze 2e divided by 4 pi epsilon 0 d. Since our target is to make an expression for small letter d, just cross multiply it. So d is equal to Ze 2e divided by 4 pi epsilon 0, inside bracket apply half mv square. This one is the distance of closest approach. You will get 1.5 mark for deriving this part. So total you will get 2 mark. If you revise 1 or 2 times this one, easily you can score that mark. Okay, just go through this one 2-3 times, then try to write your own way. Easily you can score that 2 mark. Okay, if you have any more question, please post your question in the comment box. I will help you. Okay, and if you like this video, kindly share with your classmates, your friends. Let them learn in the easy way. Okay, theory maybe you will be able to study your own way, but numerical, please visit my channel frequently. Thank you for watching. If you like this video, please share with your friends. Also put comments.